Today, I'm going to start making the final part to complete a project I started back in 1972, 52 years ago. What is this part? Stick around, I'll show you. Welcome to 3D Accuracy, where I'll talk about 3D printing, 3D product design, and 3D injection and die-cast mold design. Meet Okibo. This is a project that I started in 1972. It's a Gibson bass guitar, and I have every part to complete it except for one, and that is the truss rod cover. Now, if you're curious like I am, you're probably asking, where did this come from? Why did it take so long to make the last part? Well, there's a story that goes along with this guitar. Let me tell you the story. Now, if you don't have patience and you don't want to hear the story, just scroll ahead in the video and find out other information about creating the 3D CAD file to make this part and whatever else you're interested in. So, let's get to the story. First, how did I come across this guitar? Well, I went to jam with some people that I met through a mutual friend. Didn't know them before that. I used to play a lot of guitar back in those days. And this guitar was broken in two pieces. And all I saw originally was the neck lying on the floor. And I asked the guy, I said, what happened to that? And he says, of course, somebody had dropped it, broke the neck off of it. And it was in bad shape. It was splintered. It wasn't a clean break. And all the hardware was on. The tuners were on, the nut was on, the fretboard, of course, was on, and all the frets were on it. And I said, what are you going to do with it? He says, probably throw it away. I said, you don't want it? He says, no. Do you want it? I says, yeah, I'll take it. I said, what about the rest of it? Well, the rest of it was in another room. He went and got it, brought it back to me, and it had all the hardware on. The pickup, the pick guard, the hand rest, the bridge, the tuning, volume, and tone controls. Everything was on it. Everything was on it, except it was badly, badly broken. I deemed that it was not repairable. So that's why I made a new body and a new neck. Now, I know this guitar is somewhere, the original was made somewhere between 1961 and 1968. In 69, they changed the bridge, and they didn't always have the hand rest. That changed a little bit also. So, anyway, I don't know exactly what year it was. And I tossed the original neck, of course, once I was done, getting all the dimensions off of it so that I basically reverse engineered the body and the neck of the old guitar to make a new body and a neck. I needed some information, so that's how I did it. But I tossed the old neck, which I should not have done, because it has in the back of the neck, in the back of the headstock, in the back of the head, they always stamp the serial number of the guitar. And that can tell you what year, when it was made, that sort of thing. So I don't know when the original was made. Now, I can kind of isolate a year that it was made. I haven't done it. But on the back of the volume and the tone pots, there's stamped the date that they were manufactured, when these two pieces here were manufactured. There's a little cover on the back of the guitar. I'll show you what that looks like. There's a little cover there, and all I have to do is take that cover off and see if I can read the dates on the back. They stamp it in the back of the little metal housing that holds the volume and the tone controls. You cannot always see the date because sometimes they solder over them when they make connections back there, but I haven't done that yet to see what year the hardware came from. So That's how I first got the guitar. Now, if you happen to be watching this video and you're the fella who remember giving me the old guitar, get in touch with me. I'd like to have a conversation with you. Let you know that the guitar you gave me did not go to waste. It's still there. I still use it. Love the darn thing. It'd just be interesting to have a conversation. So, let's talk about where did the body and the neck come from? Well, the wood that I use to make this guitar is solid oak. These were originally part of tables in high school back in the Chicago area where my uncle worked. And they had these tables and they wanted to get rid of them. They were old. When my father actually got this wood originally, it was 110-year-old wood tables, and they were replacing them. So my father grabbed all the wood because he liked to do woodworking things, and out of some of it came this guitar. And it's one solid piece. Even the neck and headstock is one solid piece. Typically, new guitars are laminated. Because they do that for manufacturing reasons. They don't want to waste all the wood that they cut out of this area. So it's thinner, and they laminate the ends on it, a smart thing to do. But in my case, that wasn't an issue, so I just made it all one solid piece. That's the story of the original guitar. So let's move on to the next thing, which is I need to create a 3D CAD database. I need a file, something to 3D print so we can make a new truss rod cover. Let's move Okibo over to the other table here, and we'll start taking some measurements. I want to carefully come across the shop. Don't want to bang it. And I put my sweatshirt and a towel here to rest the guitar on. Don't want to scratch it. All right, we're in business. Now, when I made this guitar, this slot is actually longer than it typically is when Gibson makes a guitar. It usually comes right about to here, where the string's attached to the tuners here. It usually ends about there. I don't remember why I cut that deeper. Maybe I wanted better access or easier access to the truss rod nut. I don't remember, or if it was just a mistake, I cut it a little too far. So it doesn't matter, because we're going to custom make this, and what I want to do is I want to put the name on the truss rod cover. I want to put Okibo. That's what I call it. Made out of oak, and it's an EB0 bass guitar originally. So I call her Okibo. Okay, so let's get to this. We need to measure this shape so that we know how big the area is that we need to cover with the truss rod cover. Now, I've got a sketch here in my computer, and you can see that I have a center line here, and this is the center line of the assembly. I'm going to use this to create what the original truss rod cover looked like, and then we're going to modify it to fit this neck. We're going to modify it to fit this opening. All right, now it's not critical, the dimensions. It's not like I'm reverse engineering medical parts or something like that. All we need to do is cover up that opening. Doesn't have to be any fancier than that, except we want it to look nice and I want the name in it. All right, so what I did is I just made a sketch here, which is the length from here to here is the length of this opening here, and then there's the width. So we're going to measure a couple other points, and we're going to get the rest of the shape in here so that we know how large the hole is we need to cover with the parts we're going to make. Okay, so we just do a little measuring here, and we've got 1/2 inch. Is that right? Yeah, we've got a 1/2 inch width there, so we've got a 1/4 inch radius up at the top. Let's get a 1/4 inch radius in there. Come on, there we go. All right, let's get a radius roughly from here
to there, and we'll dimension that. There, it's almost 1/4 inch, 0.25. Bingo, got it. All right, now let's make a line. We know we need to be tangent from there, and I know it's on an angle. All right, so let's just get that from here to here. Oh, and by the way, I'm using Creo Parametric software, if anybody's interested, made by PTC. I've had it for a long time. I've been using it since the mid-90s, 1995. Okay, now let's take another measurement here. What I want to do is, there's a point here. You see how this is on an angle? There's a point here, a point here. I want to see roughly where those are. It's about 875 from the nut, and it's roughly 600. Yeah, 600 or 0.6. I mean, let's do this. Let's do it this way. From here to here, 0.875. Now, I've got a line that goes roughly from here to the corner, and no, come on, let me go. From here to there. Okay, now you can see this shape right here is pretty close to what we have. Now I know this point, we measured that. Where did we go here? Come back. There we go. And we're pretty close to what we have here. Not perfect, but it doesn't have to be. We only have to cover it. Okay, so now that we have what is on the head of the guitar, this shape here, and we know where we need to design our part, how it needs to sit in relation to that, we need to come past it so that you don't see that opening anymore. Now, the next question is, how the heck are we going to get a truss rod cover to get the dimensions from? Would you believe you can actually buy these truss rod covers, and they cost anywhere, I've seen them online, anywhere between like $7 and $20 sort of a thing. But because I have this slot cut longer, they won't work. So I need to make my own. And secondly, I want to put the name in it. Okay, now what we need is a truss rod cover to measure. So let's close up Okibo's case here. Move it out of the way. Okay, and lo and behold, magic. We've got another one. All right. Let's get over here, get it on the table. Careful, careful. Okay, and this is how we're going to get our truss rod cover dimensions. I have another guitar here. All right, where are you? There you are. Okay, and since we're finished with Okibo, all we needed from Okibo was to get the only thing we needed was to get the size of this opening so we know. Now, we're finished with Okibo for now, so let's put it back in the case. All right. There we go. All right. Now, this one. Ah, what a beautiful thing, isn't that? Oh my goodness. Here's what the truss rod covers look like. So what I need to do is measure this shape and get an original shaped truss rod cover in the CAD file, and then I'll adjust it, make it longer to fit on Okibo. Now,
what I want to do is take this one. I haven't named this guitar yet. Eventually I will. All right, but I want to take it out of the case, and let's bring it across the shop here and lay it down on the table. Okay, there we go. The head was actually touching the table a little bit, so I moved this back underneath to change the angle. All right, now I want to close the case. Okay, all you guitar nuts out there, if you're like me and you love your instruments, one thing you want to do is get a desiccant pack like this. Throw it in your guitar case. I'm going to close this because the inside of the guitar already has the correct humidity level. The desiccant pack will actually absorb moisture and release moisture. So I don't want to leave the case sitting open because then it's going to change the humidity balance in there. Once I put the guitar back in, of course, now that I have it out, it's going to acclimate to the room, and so its humidity level is going to be different. It's important to maintain the humidity level on your guitar because the fretboards expand and contract with the humidity. And that's a bad thing. That can be a real bad thing. If there's too much moisture, it can cause mold, can cause swelling. If there's not enough, it can cause shrinkage. And when the fretboard shrinks, the frets do not shrink. And so on guitars where you don't have a binding, like on the neck here, those frets can actually stick outside the edge of the fretboard, and when you move your hand along the neck, you're going to feel that. You're going to have all these little sharp dun, 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 dun. So maintaining the humidity is a smart thing to do. Okay, so what we want to do next is we need to measure this guy, and we need to get this shape into the computer. Okay, so we've got another part. So let me do a little setup here, and then I'll get back. Okay, have the next two pieces, the truss rod cover bottom and truss rod cover top. You see there's two pieces. There's a white layer, there's a black layer. And so I'm going to create that as two separate pieces because when I 3D print it, that's how I have to make it. These were probably done in some sort of a similar fashion, although they probably were not injection molded. They may have been machined or something like that. I don't really know. Doesn't matter. So anyway, what I did is I laid one of the pieces over the top, and I just did an outline sketch of it for its size, and that is this truss rod cover. That's what that is. And you see there's a cayenne colored line here. That is the nut. That's where the nut is. That's this part that holds the strings. On the original sketch I did from EB0, I modified the shape a little bit. I didn't have it quite right, so I tweaked it and have that correct now. Here's where the nut is on EB0. So what I want to do is I want to move this over, this sketch over, so it aligns with the nut on this truss rod cover. Now, why am I doing that? Okay, the reason is it's just mostly habit. Because whenever I design a part, I design from the center out. I always want to know where the center of the part is. And because the sketch for EB0 is longer, its center right here is in a different place than where the center for this truss rod cover is going to be, which is right here on this datum plane. Okay, now the reason I work out a center is because most injection mold makers and die-cast mold makers and people who do a lot of machining, they work out of centers. They'll take a block of steel. At least when I was working in the mold shops, that's how I did it years and years ago. You take a block of steel, you put it in the machine, you tram the block. That means find the center of the block and then go ahead and cut and position everything from there, because all the screw holes, all the shapes are all designed from the center of the part. And so that's why I'm doing this. So right now, these two centers aren't anywhere close to where they need to be in relation to each other. So I'm going to move the sketch for EB0 over
by this amount right here, 0.3875, because that's the distance from the edge of the nut on the sketch and the edge of the nut on the truss rod cover on my Les Paul guitar. Okay, so let's first move that over 0.3875. Okay, so what we need to do here is close this. We want to edit this sketch. I want to go here, edit, and we want to take this dimension, 0.5 minus 0.3875, enter, zoop, and now the two centers are 0.125 difference in relation to each other. Okay, so what will happen is, there we go. Okay, regenerated that and realigned them. Now, here's the truss rod cover that's on the Les Paul. And you see how it's short? It doesn't come to the edge of the opening on Okibo. So there's my difference. That's how much difference there is between this truss rod cover and the truss rod cover I need to make for Okibo. So what I'm going to do is I'm going to copy this. We're going to reverse engineer this little truss rod cover to get its shape in here. Then I'm going to make a copy of it to modify to work on Okibo. Okay, so that's what we're going to do. So what I'm going to do here now is let's go over to the other window, go to the bottom part, which is the one that's on the bottom, and this is it. And this is just the square outline. This is the length and width of this truss rod cover. So now I need to get some of this shape. I need to measure this shape so that it looks like that and get that into the computer. So let me do a little bit of that, and then I'll show you what it looks like. You don't need to watch me measure each little feature and copy it over. Here we go. How does that look? Looks pretty good, doesn't it? Looks like the truss rod cover on my Les Paul. Way cool. Okay, so when I measured it, what I did was, you'll notice I have a lot of dimensions on there. And how did I establish these numbers? How did I get these dimensions? Well, what I did was this. I measured it closely to see what I could get off of the part itself without taking it off. I didn't want to take this off the guitar, so, which would have been easier, of course, but I was just looking for general dimensions with the scale, because logic tells me that Gibson has been making guitars since the 1930s, maybe even before that. I don't remember exactly for sure. But anyway, they've been making guitars for a long, long time. They've been making guitars. When they used to measure things back in those days, everything was fractional. Okay, it wasn't thousandths of an inch like on the rulers that we use. Where are you? Come here. There you go. It wasn't thousandths of an inch. It was all fractions, like on the other side. Okay, so what I did was I got the dimensions close, and then I just simply looked at the chart. Okay, this chart used to hang on the wall in my father's injection mold making shop. We used to build a lot of injection molds, and this was always hanging on the wall in case we needed to do a number. So as an example, you take a number here, 5/32, 156 thousandths of an inch. So when I measured with my scale, if I had a dimension that was close to that, I would just figure that's probably what they were doing, because it's 5/32 of an inch. It's a fractional dimension. That's how they used to dimension everything back in those days. So that's how I came up with all these numbers here, even though they're in thousandths of an inch, like 312.5, that's 5/16. Half an inch, of course, is half an inch. 156 is the dimension that we were just talking about, the 5/32. So that's how I established the dimensions. I just tweaked them until they equaled fractional dimensions. Same with this one, 437, that's half of 7/8, 785 or 875. So that's you look on the chart, 437
Right there, 437.5, 7/16. The chart's been damaged. But it's 7/16. So that's how I came up with the numbers. All right, so now let's go ahead and make this part. All right, we'll just, and this is just a sketch right here now. So where are we? There we are. Okay. Okay, so this is just a sketch, and then I'm just going to use the sketch to create the protrusion. So we'll just, okay, we'll accept that sketch. Now let's go over here. Whoop, come back here. There we go. Looks pretty good, doesn't it? Okay, so now I'm going to extrude a shape, and I've already measured this. This is 70 thousandths of an inch thick. So I'm just going to put half of it is going to be white, half of it is going to be black, because we got 2 layers there. Okay, and I measured the pick guard on Okibo. I went over here and I measured the pick guard because it's the same. See, it has that black and white, and I measured this from here to here, and it's 70 thousandths, so we're going to go with that. All right, because when they made these, they probably made them all at the same time, and so the truss rod covers and the pick guards were probably all the same stock material, and they just cut the shapes out of it. All right, so let's make that, we'll make that 35 thousandths thick. All right, so we'll come up here, 0.035 is how much we want to extrude. Placement, define, we want to draw it on this datum plane with that datum plane to the right. Okay, and then we'll just take offsets and we'll do it this way. Wait, let's go back, change my mind, go back, offset, let's do a whole loop, do the whole thing all at one time. There we go, isn't that beautiful? Okay, now let's loop the screw holes. Oh, now I don't want to do these screw holes because these screws, this is the head of the screw. This is how big the diameter of the head of the screw is. I got to figure out what that hole is going to be. So let's just go ahead and close that and say okay. And there we go. There's our little protrusion. There's our part right there. Now let's go over here to the other page where we had the assembly, and there we go. Now you see this feature right here, this is Okibo underneath there. See how that works? Now I can see how much I have to cover. Now, what I can do is I can measure the distance from here to here, and then I can lengthen this by that amount so that this part will stretch out and it will cover over Okibo. All I got to do is figure out what the screw hole diameter are, and I don't really want to pull a screw out of there. Don't really want to do that. I don't like messing with that guitar. That's my primary one. And what do we have here? We got the screws on the, those are going to be larger, I believe. What are we going to do? All right, let me pull one of these and see how close they are. Wait, I know, I can measure it first. What did we make the hole? I'm thinking. See, I'm thinking while I'm doing this. Okay, let me pause this for a second and I'll come back. Okay, I pulled a screw out of Okibo, out of the pick guard, and I made the hole in the truss rod cover the same diameter as the hole that's in the pick guard. Now, I decided what I'm going to do is, this is actually the bottom part, what will be the white here on this particular truss rod cover. It's the white piece on the bottom. Now, I need to make accommodations for the head of the screw depending upon what kind of screws I can find. Now, here on my Les Paul, they're like button head screws. On my on Okibo, they're like flathead self-tapping wood screws. So I have to see what I can find at the hardware store before I actually print these parts so that I make sure the holes are correct. And if I need a counter bore in the top piece of the truss rod cover, I'm going to have to make sure to accommodate for that. So anyway, there's the part,
as it stands so far. Now, what I want to do is I'm going to add some radiuses in a couple of the corners, and then I'm going to put the draft on the outside. I don't know if you can tell, but there's an angle around the entire outside of the part. And when I make the black part, of course, it's going to be smaller than the white part underneath it because of that draft angle. So I need to draft this part first to get a draft on there, and then I will choose that edge to create the part on top of it. And then when I put the draft on that, it'll have that nice angled surface. It'll look like it was all chamfered together, but it wasn't. Then I also want to put an alignment feature in here so I can put the two pieces together and glue them to each other so that they stay together. And so I need to align them also from the top piece and the bottom piece. Then, as far as the engraving goes, to put the name in, what I want to do with EB0, and it looks like on this, it looks like they may have stamped that logo on top of there. Stamped that name. It says Classic is what it says from the other side. But it looks like it may have been stamped on there, not pad printed, not engraved. But what I'm going to do on EB0 is I'm going to actually engrave it in the part a little bit and then probably paint it. Now, the other option, what I could do is something like this. I have this part, and you see how this is positive in one and negative in the other, so that you can put the two pieces together then and line them up and push them together and the letters come through. But I don't want to do that with EB0. It's a little too time consuming. So I'm just going to go ahead and do it the other way. I'll do it like I have these numbers here. I'll just recess it, engrave it a little bit, and then I'll go back in and paint that white after the fact in order to get the name in there. That would be the easiest way to do it. So what I have to do now is put some radiuses on here, put the draft, and I can create the other part on top of it and get the engraving in there, and we'll see what it looks like. I hope you really enjoyed this video. If you're ever in need of 3D product design, 3D injection mold design, 3D die-cast mold design, or 3D printed prototypes or production parts, please feel free to contact me. You can find contact information in the video description. I look forward to hearing from you and to being of service to you. Thank you for watching. As always, I appreciate it. See you on 3D Accuracy's next video.